Hello, beautiful people, and welcome. In this video, we are going to go over everything that will be on your quiz. Now, this is your second quiz. We did combine Module 2 and Module 4 together. Typically, we don't do that. So we're going to be working with absolute values. We're going to be working with adding and subtracting polynomials. Let's go ahead and start with Module 2. On Module 2, we've been graphing absolute value, and we solved absolute value. So for graphing absolute value, we're going to identify our translations or our transformations. What happened? And our most important two pieces of information is this one here and then this one here. Remember, if it's inside the function, if it's inside the bubble, then you are working with the opposite. So in this case, your h value is a -3. Your k value is 5. Now, why is that important? Because that is your vertex. Make sure you have the opposite of 3. Now this negative here tells you that there's going to be an x-axis reflection. And this 2 tells you that there's a vertical shift, or excuse me, a vertical stretch by a factor of 2. So now we have our vertex. We're going to do a quick t-chart to find out two other values for graphing. I always like to write my vertex in the middle. Here's your input. Ooh, let's find another marker. That one doesn't work. Your input is going to be your x. Your output is going to be your y. So for your input, we have -3, your output 5. Where did we get that? We got that from our equation, finding out the vertex. So I'm going to choose the number, the pretty number. So I'm going to choose a number above 3, and I'm going to choose a number below 3, in this case, negative. So I'm going to choose, let's do -2, which is larger than -3. And I'm going to choose -4, which is smaller than -3. Now what I do with those is I'm going to come in here and take the equation, which is -2. Let me change markers here, see if I can use a thicker pencil. -2, that's still, you guys can see it, it's okay. I can write in pen. Third time's the charm, -2 times the absolute value of x plus 3, absolute value plus 5. And what we're doing is we're inputting that value in place of x. So in this case, I have a -2 in place of x. -2 plus 3, that is a +1, still in the absolute value section. So I have -2, excuse me, let's do the absolute value first. So -1 absolute value is 1. In this case, we have a +1. The absolute value of a positive number is still positive, and they are attached by multiplication. So make sure you multiply first. So I have a -2 plus 5, which gives me a +3. So my input was -2. My output is +3. My input was -2. My output was +3. Excuse me. Let's do that one more time. Running out of room here. That's okay. I'm just going to do it off to the side here. -2 times x plus 3, absolute value, plus 5. Now our second input is a -4. So here's -4 plus 3. -4 plus 3 is a -1, absolute value. Don't forget about that. Still multiplying by -2, still adding by 5. Absolute value of -1, like I mentioned before, is a positive. Still have that multiplication. So we have -2 times 1, which is -2 plus 5. We have still 3. So our input was -4, our output was 3. Moving on here, let's graph. -3 and 5, -1, 2, 3, +5, 1, 2, 3, 4, 5. Here's your vertex. -3, 1, 2, 3. Oh, we already did that one. So let's do -2 and 3, 1, 2, 3. Here, -2 and 3. And we have -4, 1, 2, 3, 4, and +3 here. Using a ruler or a straight edge, we're going to create our arrows, one on each side. And we have graphed the absolute value. Moving on to question number 2, it says, when looking at the given equation, how do you know if a reflection has occurred? So in this case, looking at the equation, and the equation was, let me copy it down, -2 times x plus 3 plus 5. So looking at this equation, we know that a reflection occurred because we have a negative outside the function, the absolute value function. And I'm going to abbreviate absolute by writing ABS, so absolute value function. Since we have a negative out in front, that means it's going to be flipped over across the x-axis. Moving on to question number 3. There's 2. It's asking us to solve the following equations. So for A, let's go ahead and solve. Step number 1 when solving absolute value equations is to get the absolute value by itself. This is a 7. So what I'm trying to do is I'm trying to get this 7 minus x alone. It is currently attached to this negative 3. It is attached to negative 3 by multiplication. So I'm going to divide by negative 3 both sides. 3 goes away, negative goes away. I'm left over with 7 minus x in the absolute value. And I'm left over with negative 15. Now this is super important for you guys to see. I am left with just my absolute value here, which is good. However, I am left with a negative number. So this is very important to know in step number 1. When you isolate your absolute value, this has to be positive. If it is negative, therefore your answer is no solution. The reason the answer is no solution, that is because after you isolate your absolute value, this has to be positive. In our case, it is negative, so our answer is no solution. Moving on to B. Same thing, let's go ahead and isolate it. So I'm going to, there's a lot of things happening. There's a times 3 and there's a minus 2. So I'm going to add 2 to both sides first. This is 49, 50, 51. I'm going to now divide by 3. And again, our objective here, our goal is to get the absolute value, this guy here, by itself. 51 divided by 3, I'm going to use a calculator for this. And that gives me 17. And now I'm doing a happy dance because 17 is positive. So we do a mental check. Absolute value can equal a positive number, so therefore we can continue. Now when we continue, I'm going to shift this over here, see if I can grab another color. When we continue, we're taking this here, we're copying it down twice. So I have 3 minus 2p is equal to 17, and I have 3 minus 2p is equal to 17. One of them is the original. In this case, original is 17. One of them is the opposite. So if you originally have a negative, that can't happen, right? So one of them is positive, one of them is negative. You can do a positive negative in this step because you've already checked that this absolute value is already equal to a positive. We just need to solve for p now. Let's go ahead and do that. This p2 is attached to negative. So this negative does not belong to 3. This negative belongs to 2p. So this 3 is on its own. I'm going to subtract 3 both sides. If you'd like, do dotted lines to keep track. I have a negative 2p is equal to 17 minus 3, that is 15. Oh, 14, excuse me, 14. And we're going to divide by negative 2. P is then potentially equal to 14 divided by negative 2 and negative 7. Now, it's okay that P could be negative. As long as we checked the negatives here, P can be negative. Let's do that one more time. Again, we're going to subtract 3 both sides. Negative 2p is then equal to 17, 18, 19, 20, negative 20. Divide by negative 2 both sides. P is potentially equal to positive 10. Now, how do we check? Well, we check by plugging these values into the original equation, not this one. We're plugging it into the original equation. So let's do that here. So our original equation was -2 plus 3 times absolute value of 3 minus 2p equal to 49. We're going to do this twice. One time for p equal to, what was it? It's -7. And one time for p equal to +10. So when I plug them in, I'm going to be replacing this p with one of these numbers. Let's do that. -2 plus 3 times absolute value of 3 minus 2. Now we have times -7. And you don't have to set it equal to 49 because we don't know if it equals to 49. You can just do the one side first. And let's do the other one. -2 plus 3 times absolute value of 3 minus 2. Again, now instead of p, we're doing 10. And then seeing what that equals to. Now here you're not solving anything, you're simplifying. You are checking if it actually is equal to 49. So you're not moving anything around on each side. You're just simply doing steps. First step is to evaluate whatever's inside the absolute value. So I have absolute value of 3, -2 times -7 is a -14. Ooh, positive. Negative times a negative is a positive. I still have my times 3 outside, and I still have my -2 on the outside. 14 plus 3, 14, 15, 16, 17. Absolute value times 3 plus 2 minus 17 times 3, checking with the calculator here, is 51. Oh, before I even do that, what is the absolute value of a 17? Absolute value of a positive number is that number. So now we can do the 17 times 3, which is 51, plus 2 negatives, which gives me a 49 positive. So looking at our original, that does equal to 49 here. So therefore, p equals to -7 is one of our solutions. Let's check for 10. Same thing, inside the bubble, inside the absolute value first. 10 times 2 is 20. Keep the negative since we do not have two of them. 3 take away -20, or 3 minus 20 is -17. Times 3 plus -2. The absolute value of a negative number is always positive. Oops, so we took our absolute value, so we don't need that. Times 3 plus -2. As we saw earlier, 17 times 3 is 51, plus and 2 negatives, which gives me 49. So in this case, we have two solutions. One of those solutions is -7. One of those solutions is 10. So if we look here, back to where we originally solved, you can, for your answer, just simply box these and say both have been checked, like this. Sometimes you're going to see your answer in brackets, -7, 10. So this is not a coordinate point. This does not belong on the graph, but it is -7 and 10 this way. All right, let's move on to module 4, adding and subtracting polynomials. Question number 1 is asking us to write the given polynomial in standard form. Now in standard form, it is in decreasing exponential power, meaning you're looking at all the exponents. If it doesn't have an exponent, that means the exponent is 1. We're just mathematicians, and mathematicians are lazy, so we typically don't write that. So looking at the terms, make sure that you are grabbing the symbol in front of it. For example, 4x cubed is negative. 6x is positive. 3x to the 5th power is negative. Now, if you look here, let's go ahead and write our answer. So the one with the largest exponent is 5. So I have -3x to the 5th. Next one we have is 3, which is a -4x cubed. Then I have simple x, which is +6x. And then I have this number. It is positive since there is no symbols in front of it, which is +5. So looking here, it says how many terms does the following polynomial have? So this is a little bit of a silly question. That is a typo. If you have a polynomial, that means you have multiple terms, but I've given you only one. So technically this is not a polynomial. This is a monomial, this one here. So let's go ahead and change this question just to give you more of an example. So I'm going to just write random stuff here. So 3rq plus 5x minus, oh, that's a plus, 5 minus 4x, something like this. So let's say we do have a polynomial, and what you're looking for is adding and subtracting. So 5 is negative, 5x squared z cubed r is positive, and you're looking for these symbols in front. That is what they belong. Now, every single term here is grouped together, being separated by pluses or minuses. So in this case, I have 1, 2, 3, 4, 5 groupings, so I have 5 terms. Is the following expression a monomial, binomial, or a polynomial? Which we kind of already discussed. Since this right here is grouped once, there is no addition subtraction in it. This one here is a monomial. There's just one term there. Moving on to question number 4, what is the total degree of the following polynomial? So total degree, how you find that, it is the largest exponential value combined in a term, and I'll show you how to do that. So for this term here, and this term here, you're going to calculate what the exponential total value is. So I have 6, 7, 8, 9, 2, remember if there's nothing there, that's a 1, so 2, 3, 10, 11, 12. So this is the exponential values. I took all of the exponents and I combined them. Now we're not actually combining like terms. I'm just saying, hey, what's the total highest degree of that term? Since the total highest degree is 12 in this term, that means the total degree of the following polynomial is 12. That is the highest degree. Moving on to question number 5, evaluate. So when you see evaluate when x is equal to -3, you're substituting or plugging and chugging. So you're going to take that, you're going to substitute it into your x value or whatever variable they're using for the example. Copy down the question. I have 3 times 5. Now instead of your x value, I'm going to be replacing, there's 2 x's, I'm going to be replacing that with the value of -3. After that, PEMDAS and order of operations. So this is parentheses, or these are parentheses. We do those first, and we do what's inside first before we touch anything on the outside. So I have -3 squared, which is 9, minus 9 times 3 is 27. I have a negative and a negative, so I have 27. And I still have this multiplication of 3 on the outside. 9 times 5 is 45, plus 27 is left over. And these are in parentheses. This is not an absolute value. This is parentheses. So I get 45 plus 27, and I get 72. So I get 3 times 72. 72 times 3, and that is 216. Question number 6 is asking you to simplify. When they're simplifying like this expression, this means combine like terms. When we combine like terms, we are looking for the same letters, same variables, and the same exponents. So I'm looking here, and I see I have a 5mn squared. And I'm looking and I see 1 positive mn squared. So those are the same. Next up, I see I have a negative 8m, a negative 10m, and a positive 3m. So you're going to be combining these two together, and you're going to be combining these 3 together. And now when you're combining the numerics, the variables stay the same. For example, I'm going to keep it as mn squared here, and I'm going to keep this one as m. 5 take away 8, that means I have 5, 6, 7, 8, a negative 3. Here I have, oh, I did that wrong. You guys, did you see that? I hope you're laughing at me. I saw that these two were together, and I did them. These are not like terms. 8m and 5mn are not like terms. What are like terms are 5mn and 1mn squared. So this one and this one. So 5 plus 1 and m is 6mn squared. Now the negative 8, again, symbol comes with the number. It's in front. I have a negative 8 and a negative 10. That means I have negative 18m plus 3. So that's 15, 16, 17, 18. I have negative 15 m's. So what is my simplification? My simplification for question number 6 is 6mn squared minus 15m. Question number 7 is asking us to simplify. Note that we are subtracting this expression. So that means I need to, step number 1 is distribute this negative and then convert it to a positive. So I'm going to rewrite this as 2x squared minus 5x minus 7. Then I'm going to multiply this by negative, change this to addition. So I have a negative 7x squared plus 3. And now I'm going to add. It's your choice if you want to add vertically or horizontally. I'm going to choose to add vertically. So I'm going to shift it over here and say 2x squared minus 5x minus 7. Now make sure that if you don't have a term, you write a placeholder of 0x whatever. So for example, here I have a negative 7x squared. Squares are on top of each other. I do not have an x, so I'm going to write a placeholder of 0x, and then I have a plus 3. All of this I'm going to add. So negative 7 plus 3, that is a negative 4. Negative 5 plus 0 is a negative 5x. Negative 7 plus 2, or 2 plus negative 7, is a negative 5x squared. So this expression gets simplified to negative 5x squared minus 5x minus 4. Last question here, it's asking us to simplify. This one is asking us to add. So again, you can choose to do it the vertical way or the horizontal. So I'll do horizontal this just to show you the difference. So I have 4x cubed plus 2. I should have rewritten that, but that's okay. This is a plus 8x cubed minus 5x plus 4. So I am seeing that there are some terms that are missing. When you're doing horizontal method, you don't really have to worry about placeholders. I'm going to group them together, 4x cubed and 8x cubed. And I have a negative 5x. It does not have a buddy here, so it's on its own. And I have 2 plus 4. Simplifying that together, I have 8, 9, 10, 11, 12. Then I have a negative 5x. Then I have 4, 5, 6. So my simplification of this addition is 12x cubed minus 5x plus 6. All right, beautiful people, that is it for your pre-quiz. I hope you enjoyed this video. If you have any questions, reach out to me and your quiz will look pretty much like this. Thank you so much for watching. Bye.